Okay, let's begin. Last time we left off with 3 examples. So, rational equations, x over 3. I think I've been through this on one of the quizzes. I'm not mistaken. So, as I mentioned, nothing really new to do here in terms of ideas. We're just going to combine one very old idea with the ideas we learned when we were doing equations. That is, just multiply by the LCD, and that is going to change this into a non-rational expression equation. So, x over 3 plus 1 equals 2 over 5. What's the LCD here? So we can essentially multiply the entire thing by 15. So the 15 times this, the 3 is going to cancel into the 15, leaving you with 5. And of course 15 times this is going to give me 15, 15 times that will give me 6. So now it's just a regular linear equation. So we isolate the x, that's what we do with linear equations. So I'm going to subtract 15 from both sides and divide by 5. So nothing really new there. E is going to be the same idea. What do I do here? You could also cross multiply. What do you want to cross multiply? So you mean like doing this times that? That can also work. When you only have one fraction on each side, it's kind of hard to do cross multiplication here unless you combine the left side. But that's also valid. So just write that in as well. Ultimately, cross multiplication is also multiplied by the LCD. You'll notice that you multiplied by this denominator and then that denominator. So we would have x squared equals 10 minus 6 equals 4. So our x equals plus n minus 2. One way you can see that is to just say x is plus or minus the square root of 4 equals plus or minus 2, or you could have brought it to one side, factored, and apply the 0 factor property. So this will give you the 2 and the minus 2. But I know some people forgot to mention the minus 2 just now, so it's probably safer doing this. If it's not linear, bring to one side and factor. Let's make sure you don't forget anything. What do we do here? Going to multiply everything by 3 times x minus 2. So come over here, going to distribute. So in the first case, the x minus 2's cancel, and I'm left with 3 times x over over here, the 3's cancel, and I'm left with 2 times x minus 2. Do not forget the parentheses. This times that, the x minus 2's cancel, and I'm left with 6. At this point, we can expand, and this turns out to be essentially linear. So can combine the two x's, add the 4 to the other side, I get 10. And so here I get x equals what? 2. So that's the answer, right? No objections? This is not the answer. Where did I go wrong? Forget how to expand. Well, no. You just need to remember that the equation you were given was actually not linear. It was actually a rational expression. So that age-old thing where you always have to check your answer once you're not doing. If the linear equation still holds, you'll notice that x cannot be 2. Original 0. See, x can't be 2 because I would divide by 2 in these 2 locations. So this one actually has no solution. This equation cannot be solved. Because the only possible solution would be x equals 2, but I can't actually plug in x equals 2. So that shows you why the last step that I mentioned last time, if you remember, was to always check your answer. It's very important. Once you're not dealing with something that's straight up linear, you don't have to worry about anything. You need to check your answers. Very important when you're dealing with radical equations and when you're dealing with anything with a fraction. And pretty soon we're going to look at some other functions that you have to watch out for other things too. But yeah, always make sure that your answer works out in the original. Even check it for linear, just to make sure you didn't make a mistake. So yeah, always check your answers. Not much more to do here. I kind of want to now move on to a different thing. Sort of a cousin of equations. Inequalities. Now these guys are also important for us to know how to deal with. For one, we've already seen that we need to deal with these guys when looking at the domain. Where A and B are algebraic expressions. So the claim here is not that they're equal necessarily, but that one is so these claim. This thing here. What does this mean? A is greater than this one just means A is greater than. This means A is less than or equal to. And this means A is less than. So you can memorize them in a certain order. You can also know that you automatically know the reverse relationship. You should also know that saying A is less than B, for example, is the same as saying B is greater than A. What you can imagine is that for this symbol, doesn't matter how you're reading it from left to right, what you need to know, think of the symbol like a Pac-Man. Open angle always towards the larger thing. He's very greedy, Pac-Man. Okay. So this means A is bigger than B, A is bigger than, this means A is potentially the larger one, here it's strictly the larger one, there B is the larger one, that's what you mean. The mouth always opens to the larger one. Now, we want to know how to solve these. I mean, we've looked at some before, but let's make sure that we know all the rules specifically. How to solve inequalities. Can't wait. Get something? How to solve inequalities. Does anyone remember how we solve inequalities? What's the strategy here? Yeah, where is it?
Like you can sometimes treat the inequality like an equal sign.
Yeah, treat the inequality as an equal sign. Only initially, okay? 2, you're going to solve the equality. Using techniques from the last section. What makes it different from an equality? What do you have to do next? Yeah?
Change the sign when dividing or where you multiply. I mean, not dividing by negative number.
That's true. I'm going to talk about that next, but let's actually wrap up figuring it out. Because that would be involved under step 2. But, yeah. Right, you have to test the intervals created by the solutions in step 2 to see which make the inequality true. So that means essentially like we were doing, once you find the solutions, you plug in random numbers in between those guys to see if it makes the inequality true. Because the solution could be a set of x values. It's not just going to be one guy. Now, let's get to what Laura was talking about, the caveats. There are some ways in which it's not like an equation, and it's very important that you know that an inequality is not like an equation in this case. One important caveat is, as was mentioned, if you multiply or divide by a negative quantity, you must turn the sign the other way. That's one very important thing you need to remember. So if we have, minus x is greater than 3, what that means is your x is less than minus 3. Right? Once you multiply both sides by a -1, for example, the mouth was opening that way, now it's opening the other way. So multiplying by a negative means you need to turn the sign around. The same goes for dividing by a negative. 2. Any other instance where we have to turn the sign around? There's another one. Who remembers the other one? If both expressions are on the same side, so that's important. You need to actually know. So basically what I'm saying is, suppose you know that both expressions are positive or both expressions are negative. Then you must turn the sign around. When taking reciprocals. So, example here, yes, I know that 3 is greater than 2, but what if I put 1 over each of them? It now goes the other way. A half is actually bigger than a third. Right? This is important because these guys are both on the same side of 0. They're both positive numbers. So once I take reciprocals, the sign actually turns around. A fraction with a larger denominator is a smaller fraction. So that's very important for you to know. If you're ever trying to solve something where there's an x in the denominator and you try to flip it in order to solve it, you might have to turn the sign around. Just have to be careful. This does not apply on this. Does not apply. The expressions are on the opposite side. Right, so if I say -2 is actually less than 3, then I can take reciprocals of both, but guess what? It's still that way, right? Because this is positive. It's always going to be bigger than any negative number. So if they're on the opposite sides of 0, this guy's on the left of 0, that guy's on the right of 0, reciprocals won't do anything. But if they happen to be on the same side of 0, they're both positive or both negative, once you take a reciprocal, you have to flip the sign. They are pretty much, you would do the same as the equations, except if you're multiplying or dividing by something negative, you have to flip the sign. If you're taking reciprocals, you have to flip the sign. Here's something else that I would recommend. How you approach this kind of thing is in the last case we dealt with equations. I would not deal with inequalities that way. If the inequality involves rational expressions, do not multiply by the LCD. Okay, this is one case in which you don't want to simplify the fractions. You want the fractions to stay. Why? Because where the denominator is 0 is going to be very important for an inequality. It's not important for an equation because at the points where the denominator is 0, you wouldn't pick the x value as being that point anyway. So you can eliminate denominators and not worry about them technically until at the last step. However, sometimes you're eliminating a denominator where it goes to 0, but the inequality would change signs on either side. And so you want to always know what those points are. So instead, don't clear denominators when you're dealing with inequalities. Do that with equations, but not with inequalities. Instead, what you're going to do is keep everyone as a fraction. Instead, combine bring everything to one side. Combine into one big fraction. Set both numerator and denominator equal 0. Now, the x values or input values, if it's not happened to be x, that make the numerator 0 are not in the solution if you have greater than or less than. Right? If you have less than or equal to, then those guys that you found by setting the numerator equal to 0 will be a part of the solution, so they should be included in brackets. If you don't have the less than or equal to, you put them parentheses. You cannot include them. The x values that make the denominator 0 are never included in the solution, under no circumstance. So that's that. Inequalities are dealt with very similarly to equations, except for these caveats. Multiply or divide by a negative, you need to turn the sign around. Taking reciprocals when both are on the same side of 0, you need to turn the sign around. And don't run away from denominators whenever you have rational expressions. Knowing where the denominator equals 0 is going to be very important because you can have a sign change on either one of those values. Okay? So some of you, I think all of you at this point should know, right? So if you have something like y equals 1 over x, notice that of course the denominator cannot be 0, but there's a part where it's greater than 0 and a part where it's less than 0. So knowing that x equals 0 was something you have to pay attention to, you can know when one thing is might affect the sign or another. So you need to, even though you know 0 cannot be an answer, you need to know where that happens because sometimes the graph can flip. And so I would say don't clear the denominators. You always want to know what the denominators are. You always want to know what x values make that 0. So while it's not in the solution, it's very important to pay attention to what the values are. And that's everything you need to know about inequalities. Actually, they're not that bad. Once you pick up with equations, and you just know that these behave differently in 3 situations, then you pretty much use mostly what we know from equations. So let's actually just jump into some examples. Come over here. So what we're going to do is essentially pretend it's an equal sign. Pretend this says equals, then it would look like an equation, a linear equation. So we kind of do the same thing. Isolate the x is what we want to do in that situation. We're to add, subtract 1 from both sides. Then I'm going to divide both sides by 2. So this is going to be x is less than 1. In other words now, x equals 1 is the important part. Now this is actually going to be the answer, straight up, or you can write it as 1 to infinity for integral notation. But either way, you're going to have that. Now you could check values here. So you could, for example, plug in 0, which is less than 1. Any random number will do. So notice that if you plug in 0 for x here, you get 2 times 0, which is 0, plus 1, which is 1, and 1 is less than 3, so that actually checks out. And so I know that this side will work. X cannot be equal to 1, because if I plug in 1 here, I get 2 plus 1, which is equal to 3, but I cannot be equal to 3, so that's out. And if I plugged in a number larger here, like 2, x times 2 times 2 is 4, plus 1 is 5, which is not less than 3, so that does not work. So the solution is going to be 1 or less, which is less than 1. Paying attention for too hot. So that would be the solution. Yeah, nothing much to talk about there. If instead, let's just throw in an A part. Just to give me an example. What if it were this guy? How would you do with that one? Subtract 1, isolating the x is going to be the first thing you want to do.
Divide by -2.
Okay, and what would we get?
Sign flips to
Right, the sign flips here
-1.
because we divided by a negative. Turn the sign around. Now, ultimately, even if you technically forget to do that, you should be able to pick up on what the actual answer is by actually doing the check in the original equation, inequality. So I can plug in, say, -2, and if I plug in -2 here, I would get 1 plus 4, which is 5, which is greater than 3, so this actually works out. If I plug in -1, that'll be 1 plus 2, which is 3, which is not greater than 3, so that's not there either. And if I plug in a number over here, like 0, I would get 0 here, so that says 1 is greater than 3. Well, that's not true. So over there it does not work. And ultimately, I would get the same answer. It has to be -1 or less. So testing your answer can save you, help you out, even if you forget to flip the sign around. So it's always just a nice thing within inequality to actually check your answer. But with these simple problems, like the linear inequalities, once you change the sign when you're supposed to, pretty much what you end up with at the end is going to be the answer. In other situations, it's not so clear, and you kind of have to do this to know. Questions? Now B has an absolute value in it. How do we deal with the absolute values? How do we do it?
You can separate them,
Separated how?
like absolute value of x plus absolute value of
You mean that?
yeah.
Oh, that's actually not true. Yeah, there's something called the triangle inequality. It turns out that a plus b in absolute values is always going to be less than or equal to a plus b. This is a very famous inequality. It's called the triangle inequality. So that's actually not true. One way to see it, why it's called the triangle inequality. I don't know if you guys know about vectors. But if you have something like vectors, you would know that you actually add them by the parallelogram. So if this was your vector A, and that is your vector B, then this vector is going to be your vector A plus B. And over here, this would also be the vector B. Now if you look at this as the side lengths, it turns out that the shortest distance between 2 points is a straight line. So this distance must be less than this plus that. So that's actually important inequality, so it's not true. You cannot distribute absolute values over a summation. Well, you can, but you won't get the same thing. You get something actually larger. So no, we can't distribute absolute values across a sum. You can distribute absolute values across a product. If you have this, then it's equal to that. That's actually correct. If you're splitting across a sum, it actually gets bigger the more you split it across a sum. So that's not how we deal with this. How do we deal with the absolute value then? What does it mean to be an absolute value? Here's where the definition comes in handy. Let's see, who remembers the definition again? Let's see. We did this last time. What is the definition? Okay. So basically what it means is there are two possibilities for this guy. So what this means in general, suppose you have some expression is less than some number. What does that actually mean? Well, there are two cases. This will actually give you A is less than B if your A is actually positive. Or the definition says it will give you negative A less than B if A is negative. So now what this means is, using what we know about multiplying by a negative, if I multiply both sides of this by a -1, what's going to happen? What would I get if I multiply this by a -1? Yes, well, what's the sign?
It's going to be A greater than
It's going to turn around. So in other words, what I have is that this is strictly inequality. So in other words, what I have, so ultimately what this means is that I can say A is less than B, and at the same time, the A must be greater than negative B. And I can put both of these together and just say that A is less than B, but it is larger than negative B. So whenever you have an absolute value sign, absolute value expression, less than some other expression, you can kind of open it up and make it into a double inequality, where you just take this and put the negative of that on the other side. So, i.e., if absolute value of A is less than B, then it means that your A is between both of these. That could be just something that you know now. And if your thing is actually turned the other way, what I want you to appreciate that you can do is that you just take the opposite. So if we have that the A an absolute value was bigger than that, right, then you have not this, you have the opposite of this. Now why would I rather think of it that way? Because this one's actually pretty easy to solve. This means you have not a's between negative b and b. What that means is this one tells you that you're in here. Consequently, it's going to tell you that this one means you're the opposite. It means you're out here. And so when you're less than, you take the inside. When you're greater than, you take the outside. So you can actually say that then your A is either going to be larger than B or your A will be less than negative B. And you can actually branch this off into two things. Just for future reference, in case that comes up. You can think of the greater than sign as being the opposite of this, and then you figure out, oh, that must mean I'm taking the outsides instead of the insides. So again, when you start to see things pop up in certain situations, don't just guess how to deal with them, because guesses can be wrong. Things don't have to distribute or behave the way you expect them to behave if you have no mathematical reason behind it. But what you want to do is whenever you see something like that, go back to the definition. This is why the definition is important. What does it mean to be an absolute value? If I know that, I know how to deal with this. If I don't know that, then I'm going to guess something and get it wrong. That being said, you see something like that, the next step should be clear. It's going to be what? Negative 2? Less than x minus 1, which is less than 2. Right? Put the guy in absolute value in the middle. This guy over here, his negative over there. And now what you can do is you can actually treat it as two equations at the same time. So you can actually add one to all sides. Right? So I can add one here, I can add one here, I can add one there. Right? You can do it both at once. And so what we would have is negative 1 is less than x is less than 3. In other words, x is between minus 1 and 3, strictly speaking. Now, that's going to be the answer, but really, you do want to check. So you can put in negative 1, you can put in 3, and you can plug in random values, say minus 2, 0, 4. Now if I plug in 0, I get 0 minus 1. Absolute value of minus 1 is positive 1, and positive 1 is less than 2. So that actually checks out. So we're definitely good in here. If I plug in minus 1, I would get minus 1, which is minus 2. Absolute value of minus 2 is positive 2. Positive 2 is not less than 2. So it does not include here. If I plug in 3, 3 minus 1 is 2. Absolute value of 2 is 2. 2 is not less than 2, so it does not include here. If I plug in the 4, 4 minus 1 is 3. Absolute value of 3 is 3. Not less than 2, so it doesn't work over there. And if I plug in minus 2, I get minus 3. Absolute value of minus 3 is positive 3, and positive 3 is not less than 2. So the solution is only in the middle. So it's going to be that, or that, if you want to do an interval, if interval notation was requested. Questions? So just to give you another extra example here, I'm giving examples within the examples. but it might be useful to you at someday. So let's do B2. So let's say I had something else, something like x minus 7 was, I want it to be greater than 9, something like that. Now what I could do is do the opposite. Think of the opposite. That way I don't have to be solving 2 inequalities instead of 1. So the opposite of this is that my x minus 7 is going to be less than or equal to 9. Well, that's going to mean that minus 9 is going to be on both sides. 9 is going to be on both sides, negative on one side, positive on the other. I can add 7 to both sides. And so now I know my x must be between minus 2 and 16. And then what I do is just take the opposite. Because I don't have that, I have this, which means either my x is going to be, it says here that it must be greater than or equal to minus 2, which means it should be less than minus 2, or your x is going to be greater than 16, and that's going to be that. Or, in interval notation, you would say something like minus infinity to minus 2 union 16 to infinity. So the greater than, you can break it into 2 inequalities and solve those, but it's probably nicer and easier if you don't get confused by it to actually just think of the opposite situation, the less than. That breaks up into one nice inequality that you can solve really quickly. Then you just flip it. This one tells you have to be in between minus 2 and 16. Just take the outer edges. This one is out here instead. Deal with absolute values. Okay. Give you guys 4 minutes to finish these two. Yes.
Do we have to write in interval notation? Like
If
the
requested.
answer?
If requested. So sometimes it will say write your answer in interval. If it's not stated, then either one I'll accept. But sometimes one will be specifically requested. So yeah, like I said, 4 minutes, do those. Actually, try it. And first test is a week from today. The first test is Thursday. So tonight I'll post some reviews and problems for you guys to do. It's very important that you follow the instructions that I will post with the review problems. But we are now out of time. So let's do this. Okay, someone tell me how they did this one. Move the X over. Oh, well, you said them equal to 0. You don't actually know if both are greater than, because both could be less than, right? If both were negative, that could also work. So you actually don't know ahead of time who is who. So this is why you're going to actually do the test. What things did you test? Zeros in between them. 3. Now, because we can be equal to 0, notice that if x is equal to minus 3 or equal to 2, you do get 0. So these guys are definitely a part of the solution. So there are shaded circles here. But now we have to check otherwise. So if I plug in minus 4 into here, it's nice to plug it into the factored form. So make sure that you didn't mess up with the inequalities here. Because now it's going to tell you, you don't actually care about the value specifically. You kind of just care about whether it's positive or negative. If I plug in a minus 4 here, that's negative, and that's negative. Negative times a negative is a positive. So that works. If I plug in a 0, that will give me a positive and a negative, so that does not work. If I plug in a 3, that will give me a positive and a positive, so that works. And so that's your answer. That's how you know what to pick. So in interval notation, it is from negative infinity up to negative 3, including negative 3, so you put this bracket, union to infinity, and that is your solution. Now, there is another way you could do this. You could remember that this, as written, or this, is actually going to be a parabola, which we'll talk about graphing parabolas in a little bit. But notice that it would look like going through 2 and minus 3. Notice that the positive sides are on the outside, so that will kind of also give you the answer if you could see a picture in your head. And in fact, I'm going to start talking about the picture pretty soon. Because we have to try and go. I'll talk about drawing pictures pretty soon, where that whole idea even came from. It's rocking out. It's kind of cooled down in here a little bit already, so starts to heat up again. So yeah, so if I have 2 minus 7x over 4 plus 5x, what do we do? Right, don't think cross multiply, do not think canceling the denominators. You want to keep the denominators. That's the one thing that's different with this. So what you would actually do is you bring the 1 to the other side. Bring everybody to one side and just create one big fraction. How do I create one big fraction from that? multiply this guy by 4 plus 5x over 4 plus 5x. And so I would have 2 minus 7x plus 4 plus 5x all over 4 plus 5x. Or in other words, I would have 6 minus, so that's 2 plus 4, that's 6, minus 2x all over 4 plus 5x. Now what you do is you set both the numerator and denominator equal to 0. So the numerator, 6 minus 2x equals 0. This means that your x is equal to 1/3. Right? And if you set the denominator equals 0, you have 4 plus 5x equals 0. This means that x is equal to minus 4 over 5. What you're going to do now is you're going to plot both of these. Now, the minus 4 over 5 versus the 1/3. The minus 4 over 5 is never going to be the answer because that makes the denominator 0. So that's always going to be an open circle. Yeah.
Why would it be 1/3?
Yeah.
Oh, 3. And then we're- Now the minus 4 over 5 is never going to be the answer because that makes the denominator 0. So that's always going to be an open circle. Now, the other guy has a chance of being an open circle, and it just depends on what inequality sign was in the beginning. Right? So here, there's no equal sign underneath it, so you are also not going to be this guy. So the solution is not around that. So now what you want to do is you want to test guys in between them, zeros in between. Here, this is a little bigger than minus 1. Because minus 5 over 5 would be minus 1. And then here, this we can pick, say, 4. Now you are going to plug into the fraction, this guy. So if I plug in a -1, that gives me a positive sign divided by a negative sign. So that gives me a negative, which I don't want. So that's not the answer over there. What about the 0? If I plug in a 0, I would get a positive sign over a positive sign. So that's positive, which is greater than 0. So yeah, in here it actually works. And if I plug in a 4, I would get 6 minus 8. So that's a negative sign. And if I plug in 4 down the bottom, that's a positive sign. So that's a negative, which means I don't want that. So here, our solution is between minus 4 over 5 and 3. Or you can write, say, your x is strictly between minus 4 over 5 and 3. So you do not want to kill denominators in the inequality case.
I forgot.
Because if you had done that, what you would have gotten over there, you would have only gotten the 3. And you would have probably forgotten 4 over 5. And you could have probably gotten things very wrong that way. So if you forgot that the 4 over 5 was supposed to be here, you'd have plugged in 0 and thought that this whole thing is going to be the solution. But that's not going to be true. So don't clear the denominators. Where the denominator 0 is important for an inequality. Any other questions? That's not everything. I was going to get 100 on the test. What which I'll talk a little bit more. I haven't written it yet, but it'll be about 15 problems, and you have to show all your work, so it's not going to be like a quiz. You will get partial credit, and it'll be during class time. Pretty much the whole of class time. I think 15 problems is good enough for that period of time. And it will cover everything we have spoken about so far, and some bonus problems on the next few sections. Let's actually start the next section. I don't even remember what section this is. Probably 1.9 at this point. It's called. We're going to talk about the coordinate plane. Graph. Did I talk about circles at this point? I don't think so. Yes, I do. We're going to also talk about circles. Now, we have this thing that we call the coordinate plane. Very mysterious. We've actually sketched it many times. It's this cross where the horizontal will represent some sort of input variable and the vertical will represent some sort of output variable. When we talk about functions, we forgot what those are. We'll actually remember. This is called the Cartesian plane. Does anyone know why it's called the Cartesian plane? It was invented by Monsieur René Descartes. You guys know that guy?
Who?
If you took
Yeah.
it's a philosopher, the guy who came up with I think therefore I am, that guy. That guy invented the XY plane. It was a very, very important invention. Revolutionized mathematics as we know it. It's right up there with the invention of zero. Without being able to draw pictures, we wouldn't be able to do nearly as much as we can now. But yeah, he came up with the XY plane, and because I guess they didn't want the ghetto speak, they didn't want people calling it the Cartesian plane, they said, no, we want people to say the, so we're going to take off this part and just put that. So Cartesian is actually the last part of Descartes' name. René Descartes invented this in the 1600s. Luckily, because calculus came around in the 1700s, and without being able to draw pictures, we wouldn't have calculus. So that we were lucky. René Descartes was born about roughly 100 years before Newton was. And so by the time Newton showed up, we had the XY plane, and so he could do all sorts of things with it. So now we can actually start to plot certain things in here. We can plot things called coordinates, and this has other names too. So this is AKA 2D plane, AKA the plane XY plane, AKA the plane. And so when someone says the plane, yeah, you know which one I'm talking about. So if someone says the plane, they're talking about this. They're talking about XY. Okay. It allows us to plot things in the plane, which is a pair of two numbers. Now, when we have functions, we're going to actually be giving roles to these two numbers. So this guy is going to be the input value goes here, the output value goes here. You can plot a bunch of points, you can connect the dots, and you can figure out a graph. So that was very important. Now, before we even get there, we're going to have to know how to actually measure things in the plane. So we have to talk about a notion of distance. And so to talk about a notion of distance, and then graphs, and then circles, and all that stuff, we need a help. Now, this here is something that's called a right triangle. Right triangle. Because it has a right angle in it. this side here is called the hypotenuse. These sides here are called the legs of the right triangle. Now, for various reasons, including things that I will talk about with you next time, it's very important that we know the relationship between all these side lengths. I wonder what that's going to be. So, how we could figure that out is, again, we started thinking in pictures. Let's say I took 4 such right triangles and I arranged them like so. These are all the same right triangles. So this is C, that's A, that's B, this is A, this is B, this is A, this is also C, this is C, this is C, this is A, this is B, and that's B. I can arrange the 4 triangles like this. Notice what I would have created. What's created here? We created a square. Now, the area of the square well, this is equal to, well, you can just find the area of the square, which is the length times the width. The length here is going to be A plus B. The width here is going to be A plus B. And so, length times width, A plus B times A plus B, which is A plus B squared. Or, it turns out we can find the triangle, the area of the square in a different way. We can just sum the area of the rectangles, sum the area of the rectangles, the triangles, and the inner square. Right? So there's an inside square here with length C. So that's going to be C times C, which is C squared, plus 4 times the area of the other triangles. Now the area of a triangle, we should know, is half base times height. So that's going to be 1/2 AB. And so this is going to be C squared plus 2AB. And so what we find is that the A plus B all squared must be equal to C squared plus 2AB. And so we know what this means, A squared plus 2AB plus B squared. And then subtracting 2AB from both sides, we end up with A squared plus B squared equals C squared. This is a very important relationship. It is called Pythagoras' Theorem, invented by another philosopher by the name of Pythagoras. And he was way before René Descartes. So you had this guy, Pythagoras, did this thing way back in Greece, very long time ago. René Descartes invented the XY plane, and he happened to use this fact to figure out a lot of things about how the XY plane must function. But we'll talk about that next time. Build up circles and graphs. Oh, so you have to wait like a whole other week to see this. There are no classes Monday, so the next time I see you guys is Thursday.